Okay, so we're going to start or continue, I guess, 2.4. And what I'm going to define here is the average rate of change. So the average rate of change of a function f of x on an interval a to b is given by f of b minus f of a over b minus a. So what is the idea here? You can think of a function in time. Here's a point a f of a, and here somewhere is a point b f of b. And you can think of drawing the line, I'll draw it with a different color, that connects these two dots, these 2 points. The slope of that line is exactly this quotient, f of b minus f of a over b minus a. It's y2 minus y1 over x2 minus x1. And this gives the average rate of change because essentially you can think of it like if I'm traveling in a car, then if I started at, time, say, 2, and I ended at time, say, 5, or I started at, after 2 seconds and after 5 seconds, how much have I traveled? I've traveled a net distance. So if this is a time function, so if this was time, I know I've labeled it as x, but let's just say it's time. Then so essentially in 5 seconds, or in 5 minus 2 seconds, my net distance traveled would be f of 5 minus f of 2, right? That's our net change, if you remember from one of the previous sections. So the overall average rate of change is the net distance traveled over the time elapsed. That's the kind of physical interpretation of this formula. So let's actually compute this for a given function. So let's do an example here. Let's say we have f of t being t squared minus 1, and we're looking on the time interval, say 4 to 6, and we want to find the average rate of change on this interval. And again, you can think of it as this is some distance traveled. I'm in a car, and according to a particular time, this function gives me the distance traveled. So my net change is simply f of 6 minus f of 4. I didn't ask for that, but just since it's so much related to what we're doing. And the average rate of change, let's just put that for short, ROC, that's f of 6 minus f of 4 divided by 6 minus 4. So let's actually compute all of these. So this is, well, let's first do the net change. F of 6 minus f of 4, that's 6 squared minus 1 minus 4 squared minus 1. So we have 36 minus 1, 35 minus 15, that's 20. So that's our net change. And then our average rate of change is 20 divided by 6 minus 4, which is 2. So that's 10 units of distance traveled per unit time, if we wanted to think of the same analogy. Okay, so that's pretty much what this section is about. You can do this for any function with the same formula. And the key thing to note is for lines, the rate of change is equal to the slope of the line. So for example, if I had y equals 2x plus 1 as my function, let's rewrite it as a function f of x is 2x plus 1. This is a line, right? And I could consider any time interval. So consider, we'll call it a plus h. This is, I'm starting at some number a, and I'm going up to a plus some number. So this is a time interval. You can think of it as a time interval. And we want to find the average rate of change. Find the average rate of change on this interval. Well, we just use the same formula. So we do f of a plus h minus f of a divided by a plus h minus a. And what is this equal to? This is 2 times a plus h plus 1 minus quantity 2a plus 1. Remember, when you subtract something, you got to subtract the entire thing, so make sure you put that in the parentheses. Here, the a and the minus a cancel to just give you h. So what we get is we get 2a plus 2h plus 1 minus 2a minus 1, all divided by h. The 2a and the minus 2a cancel, the 1 and the minus 1 cancel, so we're left with 2h divided by h, which is just 2. And that corresponds exactly to the slope of this line. So this is actually a proof that on any interval, the rate of change is the same, and it's the slope. So it actually is a constant rate of change. So in particular, lines have a constant rate of change, aka the slope. Okay. So let's do one more example with this, where the equation is not actually given. So let's do a little word problem. Or let me leave this as an exercise, and I'll do this in the next video. So suppose temperature is changing at a constant rate let's say inside an oven or something like that, just to make it inside of an oven, where at time 0, let's just say the temperature is probably not 0 because it's inside a home, so let's say it's 70 degrees Fahrenheit. And at time, let's say time is in minutes, so T, I'll write in minutes over here. After 10 minutes, the temperature is 400 degrees. So what is the rate of change? What is the rate of change? So 2 parts, what is the rate of change? And part 2, how long will it be before it reaches, say, 500 degrees. Okay, so let's end here, and I will continue the next video. This pretty much is the end of 2.4. We'll start this in the next video and then jump into 2.5. So that's it for now.